Something quietly shifted in the last 18 months, and most people completely missed it. Google, Microsoft, SpaceX, the US Space Force, and China's biggest telecom companies, all working toward the same goal, independently. At the same time, the goal: move artificial intelligence off the planet. Not metaphorically, literally launch it into orbit. We're talking about a constellation of up to 1 million satellites, each one functioning as a server circling Earth at 500 kilometers altitude. And the wild part isn't that one billionaire floated the idea. It's that serious engineers, serious institutions, and serious money are all treating this as the logical next step. So the question isn't whether this is sci-fi anymore. The question is, why now? What would it actually take, and what happens to the rest of us if it works? To understand why anyone would seriously consider this, you need to understand the crisis AI infrastructure is quietly heading toward. Every time you use an AI tool, any of them somewhere, a building full of servers lights up, draws power, and generates heat. Those buildings are called data centers, and they have been growing at a rate that should genuinely alarm you. A decade ago, roughly 2,000 data centers worldwide. Today, over 2,000, and they keep getting bigger. The largest ones cover more floor space than several football stadiums combined. One facility in northern France runs 24 hours a day, 7 days a week, and consumes as much electricity as a mid-sized city. Right now, data centers account for about 6% of all electricity consumed on Earth. By 2030, that number is projected to double. Some analysts see it hitting 50% by mid-century, half of everything we generate just to keep AI running. Let that number sit for a second. Half of everything. But electricity isn't even the whole story. These facilities need land in locations with stable power grids, enormous amounts of fresh water for cooling, and they are subject to local taxes, regulations, and governments. For companies used to growing without friction, those constraints are starting to feel very tight. So here's the logic, and once you see it, it's hard to unsee. What if you could build infrastructure somewhere with unlimited space, no land costs, no water bills, no tax authority, no zoning board, and a free, uninterrupted power source 30% stronger than anything you get on the ground? That place exists. It's called low Earth orbit. SpaceX has formally filed with the FCC to launch 1 million orbital server satellites. China is planning 200,000. And rather than dismissing it as a PR stunt, Google and NASA are all commissioning technical feasibility studies. The concept is straightforward. Instead of one giant building with thousands of servers, you have thousands of tiny satellites, each one an independent server with its own solar panels and laser communication links. Distribute the computation across the whole constellation, connect it all with light-speed laser links similar to what Starlink already uses, and you've effectively built a data center the size of a ring around the Earth. No landlord, no regulator, no power grid dependency, just pure, unregulated compute capacity floating above everyone's heads. Now here's where it gets genuinely interesting from an engineering standpoint. The obvious problem with solar-powered satellites is that they spend half their orbit in Earth's shadow, 45 minutes of sunlight, 45 minutes of darkness. For a data center that needs continuous power, that's a deal-breaker. But there's a solution buried in orbital mechanics. Certain orbits, called crepuscular or dawn-dusk orbits, are tilted so that the satellite perpetually skims along the terminator line. That's the boundary between the lit and dark sides of Earth. From that position, the sun is always on the horizon. It never fully sets. Solar panels generate power continuously. It's the same family of orbits used by high-powered spy satellites that need constant energy. Each satellite in this constellation would carry around 250 square meters of solar panels, generating roughly 100 kilowatts of power. And the full constellation would form a thin, permanent artificial ring passing over both poles rather than around the equator. The physics checks out. That's part of why serious people are taking this seriously. The number that makes headlines is 1 million satellites. It sounds like a marketing exaggeration, and in some ways it is, but let's check the actual arithmetic. In 2023, all of Earth's data centers combined consumed roughly 350 terawatt-hours of electricity. That's about 40 gigawatts of continuous draw. If each satellite produces 100 kilowatts, you need 400,000 of them just to match today's infrastructure, before accounting for explosive growth. So SpaceX filed for 1 million, knowing regulators will push back. Because that's genuinely the ballpark needed to be competitive at scale. The number isn't pulled from thin air. It falls directly out of the energy math. What is pulled from thin air is the part where SpaceX describes this as the first step toward harnessing the total energy output of our star. That would be a Kardashev Type 2 civilization, a hypothetical society that wraps its sun in a megastructure to capture every photon it emits. 1 million satellites with 250 square meters of panels each gives you the surface area of a medium-sized city. The sun's total output requires something closer to 280 trillion square kilometers. So maybe leave that part out of the pitch deck. Here's the first thing the animated concept videos conveniently skip. People assume space is cold, so running servers up there must be easy on the thermal side. The opposite is true. On Earth, heat dissipation is almost trivial. Hot air rises, fans push it away, done. In vacuum, there is no air. The only mechanism available to shed heat is thermal radiation, which is dramatically slower and harder to engineer. The International Space Station, housing 6 people and their relatively modest electronics, requires over 300 square meters of dedicated radiator panels and a pump system weighing 350 kilograms just to maintain livable temperatures. Now imagine replacing the crew with racks of high-performance AI compute hardware. The radiator area required would rival the solar panel area. That adds mass, complexity, and cost to every single satellite in the constellation. It's a solved problem in principle. Spacecraft engineers handle it all the time. But it is absolutely not free, and nobody hawking the vision ever mentions it. Now for the part that gets genuinely uncomfortable. Starlink currently operates around 7,000 satellites and already had to execute over 300,000 collision avoidance maneuvers in a single year. That's roughly 800 per day, automated systems constantly nudging satellites out of each other's paths. Scale that to 1 million objects sharing the same orbital shell, add the tens of millions of debris fragments already up there, and the risk of a cascading collision chain becomes a real civilizational problem. What's called Kessler syndrome, one bad chain reaction and low Earth orbit becomes inaccessible for a generation. Then there's the launch impact. Every rocket burns propellant and deposits black carbon, alumina, and water vapor directly into the upper atmosphere. Current mega-constellations already account for a measurable fraction of human-caused atmospheric damage. A constellation 10,000 times larger doesn't scale that impact linearly. It dominates it. And every piece of hardware launched is built from rare earth metals and precision electronics that will never come back. Thousands of tons of finite resources, permanently removed from the planet's material economy, with no return. Here's what actually stands out when you read through all of this coverage. Every single article, every feasibility study, every announcement, they all treat AI's growth as a fixed law of nature, as something that simply must be accommodated, whatever the cost. Nobody stops to ask whether we want to accommodate it. The companies hitting Earth's physical limits aren't asking whether to slow down or change direction. They're asking how to escape the planet so they can keep accelerating. But the escape isn't real. The factories building the satellites, the rockets launching them, the atmospheric damage from those launches, all of that stays here. At what point does the infrastructure we're building start serving us less than we serve it?